Okay, so today I'm going to be doing some GCSE maths questions on Pythagoras Theorem. You can find all these questions at mathsmadeeasy.co.uk along with all the answers as well. Okay, so this topic is assessed typically at grades 3 to 6, which means it's going to be on both the foundation and the high paper. So the questions that I'm going to do today are going to start at the lower end, so we're going to start with level 3, and they're going to get progressively harder all the way up to 6. Okay, so let's have a look at the first question. The first thing that we're told is we've got an ABC, which is a triangle, which has got a right angle. Okay. So we're then told that AB is equal to 6 centimetres, and then AC is equal to 8 centimetres. Okay, and the thing that we need to do is we need to calculate the missing side, which is BC. So the side that we need to work out is this one here. Okay, so we know that this is a Pythagoras question. This is a triangle with a right angle, and we have one missing side. The first thing I do for all of these questions is I always write down our formula. So the formula is that c squared, which is going to be our hypotenuse, which we'll label in a second, is equal to a squared plus b squared. Okay, so next thing is to label our triangle. So the side that's opposite the right angle is always c. And then you can call one of the other two sides a and the other b. Doesn't matter which way you do that. The next thing is to sub in our values. So we sub in the values for a and b. So we've now got c squared is equal to a squared, which is 8, plus b squared, which is 6. Okay. We then solve this, so we have 64 plus 36. So c is therefore equal to the square root of 100. And then we can just say that c is equal to 10 centimetres. Okay, so that's the kind of basic question that you're going to get. So you'll be given a triangle with one missing side, and you've just got to use the formula to work out what that missing length is. Okay, let's move on to the second question now, which will be pretty similar. So it's still level 3, so let's have a look at this one. Okay, we're told that EFG is a right angle triangle, and we've got two lengths. So FG is 6 centimetres and EG is 15 centimetres. And we need to calculate the length of the missing side, which is EG. So the missing side this time is this length here, so E to G. Okay, so this is pretty much an identical question apart from the triangle is being rotated. So we've got a hypotenuse with a missing length here, and we've got the same thing here. So we just need to do the exact same working out and we'll get the correct answer. Okay, so let's label our triangle. So opposite the right angle is C, and then we'll call this one A and this one B. We then write down our formula, so c squared is equal to a squared plus b squared. So c squared is equal to 6 squared plus 15 squared. So c squared is now equal to 36, and then we've got, just grab my calculator, 225. So when we add these together, we get c squared is equal to 36 plus 225, which is 261. And when we take the square root of 261, we get 16.15 centimetres. So c is equal to 16.15, and we'll put another decimal place, 5 centimetres. Okay, in the question, it doesn't mention about giving it to any amount of significant figures, so the safe bet is always to do 3. So the answer is 16.2 centimetres. Okay, right, let's have a look at the next one. So those two questions were almost identical, so hopefully the next one's going to be a little bit different, and it is slightly different. Okay, so for this one we're told ABC is a right angled triangle, and AB is 7.8 centimetres and AC is 9.2 centimetres. And we need to work out the length of the side, which is BC. So this is BC here. Okay, so the first thing, again, it's the same method every single time. We label our triangle, so C, and then we'll call this one A and this one B. Then write out our formula, so we've got c squared, which is 9.2, but we'll write out the formula first. So c squared is equal to a squared plus b squared. Okay, so now we sub in our values, so 9.2 squared is equal to a squared plus 7.8 squared. Okay, We'll then rearrange to get a squared on its own, so we're going to take 7.8 squared away from both sides. So we're now left with 9.2 squared, take away 7.8 squared, and that is equal to a squared. Okay, so we're going to need our calculator for this one. So if we put 9.2 squared into our calculator, and then we take away 7.8 squared, we are left with 23.8, and that is equal to a squared. So therefore a is equal to the square root of 23.8, and when we do that, we get 4.87, but it says in the question that we only want one decimal place, so we can say, we don't need to put that there, we can say that a is equal to 4.9 as we round up from the 7, so 4.9 centimetres. Okay, right, so that's a bit of a different one. The only thing that was different though is instead of finding C, we had to find one of A or B. Same method, label our triangle as we've done, write down our formula, sub in our values, and solve. Okay, let's have a look at number 4, which is level 4 now. What level was this one? This one was level 4 as well, okay. Right, so for this one, we're told PQR is a right angle triangle, and we've got PQ, which is 5.9 centimetres, and PR, which is 6.7 centimetres. We then need to calculate the length of the missing side, which is QR. And we need to give our answer to one decimal place. Okay, so this one is the same as the first two. So all we need to do is label our triangle. So we've got C, A, and B. Again, we can put A and B either way around, doesn't matter. Then write down our formula. So we say that C squared, in fact we'll just draw on here which side we're looking for. We're looking for this one, which is C. So C squared is equal to A squared plus B squared. So C squared is equal to 6.7 squared plus 5.9 squared. Okay, we've then got that C squared is equal to, let's put this into our calculator, so 6.7 squared, and then we've got plus 5.9 squared, so that is equal to 79.7, and therefore C is equal to the square root of 79.7, which is, to one decimal place we get 8.9 centimetres, and you don't need to write C here, so just put 8.9 centimetres. Okay, so that one was 3 marks, so I think you got one more mark for doing that. Oh no, that one was 3 as well. Okay, so similar questions, these two, both 3 marks. So let's have a look at part B now. So part B says calculate the perimeter of the triangle PQR. Okay, so perimeter, just remember that the perimeter of any shape is simply just the edges or the sides all added together. So we add C, A and B. So we'll just say that our perimeter, so we'll call it P, is equal to A plus B plus C. So P is equal to our A, which is 6.7, plus our B, which is 5.9, and then we've got plus the side we've just worked out, which is 8.9. So therefore P is equal to, let's grab our calculator again, so 6.7 plus 5.9 plus 8.9. So that is equal to 21.5, and the units is centimetres, so 21.5. Okay, next question is still level 4, and this one's slightly different. Okay, it's worth 4 marks, so this is the highest mark question so far, and it says that we need to calculate the area of the triangle. But first of all, we're told that XY is 3.7 centimetres and YZ is 4.9. Okay, so to work out the area of a triangle, we need to write down our formula, which is A for area is equal to a half times the base times the height. Now the base is this length here, and we don't know that length, so we need to work it out. So to work out this length, we're going to have to use Pythagoras. So we're going to write down our formula again, which is C squared equals A squared plus B squared. Label our triangle, we've got C, then we'll say this one's A and this one's B. Okay, so 4.9 squared is equal to A squared plus 3.7 squared. So therefore we can rearrange to get A squared on its own, which is now equal to 4.9 squared, take away 3.7 squared. So a squared is equal to, calculator again, so we've got 4.9 squared, take away 3.7 squared. So that is equal to 10.32. So therefore we can say a is equal to the square root of this, which is 3.2, and because it's not our final answer, we'll keep it to 3 significant figures, so we'll go for 3.21. Right, okay, so now we've worked out what a is, we'll write it on here, so we can say a is equal to 3.21. And we can now use our formula, so we'll just label on our base and our height. So this is our base, so we'll just put a b here, and our height is this length here. Okay, right, so now we can just use our formula for the area. So a, area, is equal to half times by the base, which is 3.21, times by the height, which is 3.7. So the area of our triangle is going to be equal to, so 0.5 times 3.21 times 3.7, so we get 5.938. So we'll put 5.938, and it rounds up actually to get a 9 there, so 939. And it doesn't mention significant figures or decimal places again, so we'll do 3 significant figures. So we'll put our final answer as 5.94. Okay, so that one was a bit harder. We needed to work out the length of this side and then use a formula for area of a triangle. Okay, let's take a look at question number 6. So this one's got a few more words involved. It's not as much reliant on the diagram, so let's have a read of it. It says that a builder places a 3.6 meter ladder, so we'll underline that, against a vertical wall as shown. So this is our wall here. Okay, so 3.6 meter ladder. We're then told to be safe to use, the base of this ladder must be 1.5 meters away from the wall. The ladder is also placed on flat horizontal ground. Okay, it then says, as our actual question, how far up the wall does the ladder reach? So we need to work out how high up this point is here. Okay, so as we're told it's a vertical wall and a flat horizontal ground, we know that this is a right angle here. Okay, so basically we need to find the length of this side. We've got a triangle and we need to find that length there. So we can label our triangle as always. So opposite is our C, and then we'll call this one A and we'll call this one B. So we can write down our formula. C squared is equal to A squared plus B squared. Sub in our values, 3.6 squared is equal to A squared plus 1.5 squared. Rearrange to get A squared on its own. So that's now equal to 3.6 squared. Take away 1.5 squared. And when we calculate this, what we get is 10.71. So therefore A is equal to the square root of 10.71. And when we do that, we get 3.27. 3.272. So to 3 significant figures, that is 3.27. Okay, so if we take a look at question number 7, we can see that it's now a level 5, so it's a bit harder again. Okay, so let's see what they've told us in the question. So we've got an isosceles triangle, which is ABC, and M is the midpoint of the vertices A and C. Right, okay, so M here, that's the midpoint. The distance from A to B is 9 centimeters, and the distance from A to C is 14 centimeters. Okay, so what do we need to do? It says that we need to work out the length of B to M. So let's stick this on. So we've got B to M here. Okay, let's try it again. So B all the way down to M. There we go. Right. Okay, so how do we go about doing this? And it's worth 3 marks. There's going to be a little bit of work that we need to do here. Okay, so the first thing that we're told is that ABC is an isosceles triangle. This is important, and we've also been told, of course, that these two sides are the same. So this means that we can say that these two lengths, let me use a different colour. So we've got this length here, A to M, if the pen wants to work properly, let's try again. So we've got A all the way to M. So this is going to be half of our 14, so this is going to be 7 centimetres, okay? And we're also told that M is the midpoint, so that just confirms it for us, that is 7 centimetres. And likewise, M to C is also 7 centimetres. Okay, we need to work out the length of B to M, so what we can do is we can put our right angle in here. And then it's simply just a normal Pythagoras problem. So the first thing to do is label our triangle. So we've got opposite the right angle, we've got C, and then we'll say this is A, and we need to find B. So we then write down our formula, C squared is equal to A squared plus B squared. Therefore we sub in our values, we get 9 squared is equal to A squared, which is 7, plus B squared. Okay, therefore we get 81 equals 49, so we take our 49 away. So we've got 81 take away 49 is equal to B squared. And then we can say B is equal to the square root of 81 take away 49, which is 32. So the square root of 32 is equal to 5.656. So to one decimal place, as they asked on the question, that is equal to 5.7. And the units, which they haven't given in this question, are centimetres. Okay, so if you didn't put the units for centimetres there, you may well lose 1 mark, so just be careful about that. Right, okay, so let's have a look at part B. So for part B, we need to find the area of the triangle, and it's only 1 mark, so it should be fairly straightforward. So the triangle is the big one. This is what we need to find the area for, this big triangle here. So again, we write down our formula, which is area is equal to half times the base times the height, and we'll just label on our triangle which is which. So this is our base, so we'll just put B here, and then our height is this one here. Okay, so we do just put in our values now. So we've got A, area is equal to half times by the base, which is 14, times by the height, which we just worked out to be 5.7. So therefore A is equal to, if we put this all into our calculator, we get 39.9, and it's going to be centimetres squared. So 39.9. Okay, let's have a look at the next question. Okay, so this one is quite a bit different to all the other ones, and it's worth 4 marks. There's going to be a bit of work that we need to do for this one. So let's have a read of it. So we're told that we've got 2 points with the coordinates 2, 3 and 7, 9, which we can see in our little diagram here. And the question that we need to answer is we need to calculate the distance between the 2 points. Right, okay. So the distance that we need to calculate is the one between the 2 points, so we need to calculate that distance. Okay, so as we've got 2 coordinates, we need to remember with coordinates that we've got x and then we've got y. So our x value for this coordinate is 2, and for this one it's 7. So that means that if we go along the x, the horizontal distance to this point here, this is going to be 7 take away 2, so it's going to be 5 units. We can do the same thing for our vertical, in other words our y coordinate. So we've got 9 and 3, so our 9 take away 3 gives us 6, and again the 9 and the 3 are here in our coordinates for the y coordinate. So now we can put in our right angle, and it's now just a simple Pythagoras problem that we can solve easily. So we label our triangle, so we've got C, and then we'll say that's A and this one's B. Write down our formula, C squared equals A squared plus B squared. Sub in our values, so we've got C squared is equal to 6 squared plus 5 squared. Solve this to get 36 plus 25, which is 51. So therefore C is equal to the square root of 51. And when we take the square root of 51, is it 51? Let me just check that. So we've got 36 plus, okay, it's 61. Okay, that didn't sound right, so yeah, 61. Square root of 61. So when we put this into our calculator, we get 7.81, and they want it to 3 significant figures, so the answer is 7.81. And there are no units, as there weren't any given in the question, as are just coordinates. Okay, so taking a look at question 9, we can see that we've got a diagram of a triangle, and inside the triangle we've got two individual triangles. Okay, so we're told first of all that MC is perpendicular to AB. So MC is the same that's perpendicular to AB. Okay, we're then told that AB equals C, AM equals X, and MB equals C minus X, which are all labelled on our diagram. Right, so the actual question says at the bottom, by applying Pythagoras' theorem to triangles AMC and CMB, we need to show that C squared minus 2CX equals A squared minus B squared. Right. Okay, now a question like this, you probably think, okay, how on earth am I going to show this? But they've given us a clue. They've said by applying Pythagoras' theorem, so we're going to have to use that theorem in some capacity for this question. Okay, so the first thing I'm going to do is I'm going to draw on these two triangles. So we've got AMC, so we start at A, go to M, up to C, and back down to A. Okay, and then we've got another triangle which I'll use red for, which is CMB. So we've got C, let's not do it from that point, let's do it from about here. So we've got C, down here, down to B, and then across. Okay, right. So the first thing I'm going to do, because I'm not sure how to do this one, is I'm just going to write down Pythagoras' theorem. Okay, so we've got C squared equals A squared plus B squared. When you've got to prove something like this, it's a case of just trying to work some things out as you go along. You know, there's not a set way to do this question. It's not directly on the syllabus. It's more of a thinking outside of the box kind of question. So what I'm going to do is I'm going to substitute the values for C, A and B from this triangle first. Okay, so we'll call this triangle 1 and we'll call this triangle 2. So for triangle 1, I'll just put a 1 here. What we can see that C, which is going to be opposite, so that's going to be C, we'll call this A, and we'll call this one B, and we'll do the same while we're here for this triangle. So opposite our right angle, we've got C, and then we'll say that's A, and we'll say that's B as well. Okay, so for triangle number 1, our C is A, bit confusing, but where we've labelled C, they've labelled it as A, so we'll say A squared is now equal to RA, which is C minus X. So remember our brackets, C minus X all squared, and then we've got plus our B squared, which in this case is H, so our B is H, so plus H squared. We'll simplify this, so we get A squared is equal to C squared minus 2CX, and we've got plus X squared plus H squared. Okay, right, so we'll leave it like that for now. And we'll move on to our second triangle, triangle number 2. So we'll do the same thing, we'll substitute in our values for C squared equals A squared plus B squared. So our C in this case is B. So we'll substitute in, so we've now got B squared is equal to, so our A, which is X, so we've got X squared. Then we've got plus the B squared, which is H, so plus H squared. Okay. Right. So now we've got two different expressions for Pythagoras' theorem here and here. So we need to try and make it look like this basically. Now what I've noticed is there's a common theme for both of these. We've got a common variable which is H squared. So we're going to have to substitute H squared for one of these expressions. So we're going to rearrange number 2. So we're going to rearrange it so we have H squared on its own. So that is equal to X squared, take away B squared. We're going to substitute number 2 in for number 1. So where we see H squared in number 1, we're going to substitute in this expression now, okay? So we are left with A squared is equal to C squared minus 2CX plus X squared. And we've now got plus X squared. Have we got plus X squared? No, we don't. I've done that the wrong way around. Okay, so when we can see that there's no X squared in this expression here, so I know that I've gone wrong somewhere. I'm just checking back over the working. Let's remove that. If we look at this line that I've done here, we can see that I've made a mistake. So H squared is actually equal to B squared minus X squared. Okay, so let's rewrite that. So we've got B squared minus X squared. Okay. Easy mistake to make, but it's a good thing that we spotted it. Right, so let's carry on now. So we've got plus X squared, then we've got minus X squared, and plus B squared, okay? We'll then simplify, so we end up with a squared is now equal to c squared minus 2cx, and then we've got plus b squared. And we just need to rearrange this now so that we've got it in this form. So what we're going to do is we're going to take b squared away from both sides, and we will be left with a squared take away b squared is now equal to c squared take away 2cx, and that is what they wanted us to show for the question. Okay, so the important thing here was I realised that I made a mistake because I saw there was no x squared terms up here, so I just checked this line again. Okay, so slight mistake, but we were able to rectify it in the end, which is good. And that is the end of the question. So this question right here is probably one of the hardest you're going to get. Level 6 is about as hard as it does get for Pythagoras' theorem. So if you can manage this question, then you should be good for any question that comes up in your exam.